We can talk about applications of parametric equations where we're talking about hitting a golf ball or throwing a baseball or launching a rocket, where we can talk about how far it travels horizontally or how high it travels. And we can represent those distances with these parametric equations. Okay? We've got things such as velocity. V is representing the velocity, and over here H is representing the initial height. So like a golf ball hit off the ground would have an initial height of 0. But there's going to be an example where a girl hits a softball from 2 feet in the air, then H would equal 2. Okay, and maybe you remember this number from physics class, talking about gravity. But anyway, we've got this parametric representation of some kind of object in flight. Example 6 is talking about 3 golf balls hit simultaneously. You've got initial velocity of 132 feet per second. And we've got 3 different balls at 3 different angles, 30, 50, and 70. So part A says, assuming the ground is level, determine graphically which ball travels the farthest. Estimate this distance. I think the easiest thing for us to do is going to be the graph. So, looking back at our model, we can talk about the first one being 132 cosine 30 degrees times t, comma, 132 sine 30 degrees times t minus 16t squared plus the initial height of 0 because it's hit off the ground. Okay? Now, when you enter this in on Desmos, I think you're going to need to put parentheses in right there. Otherwise, it's going to think the t is part of your cosine argument. And likewise, let's put parentheses here so that they don't think that the t is going inside of your sine argument. Otherwise, I suppose you could use a calculator and calculate 132 cosine 30 and 132 sine 30 and just change the decimal version. Maybe that's easier for you. Maybe that's more suitable. We'll see. So let's go to Desmos and let's graph this. Now, since we are in degrees, you'll want to make sure and put your settings, change your settings, make sure that's in degrees right there. Otherwise, it'll be all messed up. So let's see what we have. Okay, I put that in parentheses there. Okay, 132 cosine 30 times t. And then over here we'll have okay. And you can put the plus 0 on the end if you want. It's not going to change anything. But there's your parametric representation. Now, it looks like a line popped up, but that's not really a line. If you zoom out, that's not really a line. We just don't see enough of it. Change this to, I don't know, 2 pi. We can see an arc. That seems like what a golf ball might do. Okay, so let's try the others. Okay, let's graph all 3 of them at the same time. So if you look at the other 2 parametric representations, the other 2 golf balls, the second one's going to be 132 cosine 50 times t and 132 sine 50 times t minus 16t squared. And then the third one is going to be 132 cosine 70 times t and 132 sine 70 times t minus 16t squared. Again, I left out the 0 because it's not going to do anything. Let's graph them. Yeah, change the
That's not quite far enough. It doesn't quite get to the axis, so it doesn't really matter what you type in as long as it goes far enough to get past the axis. I wonder if I can just copy this. Change that to a 70. Change that to a 70. Okay, that ought to do it. And so, real quickly, you can see which one travels the farthest and which one travels the highest. And that's all we really need, I guess. We would have a graph that looks like this. Okay? So we'd have a graph that looks like this, but we haven't answered our question. Question A says, determine graphically which ball travels the farthest. Well, it's definitely this one. And which one was that? Was that the third? That was the 50-degree angle. Here was the 30-degree and the 50-degree and the 70-degree angle. This one's the highest. This one's the farthest. So we just need to estimate what those distances are. Let's go in here and zoom. .536.23 it looks like. 536.22. Okay, something like that. 536.22. Let's just call it 536.2.
Assuming you're on this level, determine the graph, which ball travels the farthest. That was ball 2, right? Ball number 2 that was hit with 50 degrees, a 50-degree angle. And that traveled, what did we say? 536.2 about. Okay, so which one travels the highest? That's this one. Okay, so you should be able to see how high that one is.
Let's zoom in on that and see how high that is. To about 240. About 240. Okay, about 240 feet looks like. So which one was that? That was the third one. The third one was about 240 feet.
Which ball reaches the greatest height? Number 3 was the 70-degree one, which was about 240